Welcome to the Trust Fund. My name is Grace.
My name is Omer.
My
Good
name is
saying.
Emily. Oh,
Oh, you're
sorry.
good.
Okay.
Okay. And so our group is group three
Hmm.
from section 0103, and we did the War and Trust, and our name was Trust Fund. Okay. So here are our victims. Welcome, welcome. Everyone seems to be dressed to the nines. Okay, so today we're going to be talking about three main topics. The first one is data analysis. The second one is trends that we found through testing. And the third thing is lessons that we learned through like the evolving of like our creation and how it was tested and kind of things that we were thinking whilst everything happened. Okay, our data analysis. We have this wonderful, beautiful picture. Great, stunning. Moving on. Okay, so this is our original free body diagram, and it's clean, simplistic. And so this was the kind of things that we had. There was seven joints, a height of like 4 inches, and like a total width of around like 22 inches. We originally didn't really have too many problems in terms of like design. I mean, the CAD was a little bit harder because some of us haven't really CADed that much. So there's a lot of like harsh angles and like not understanding some of the things that needed to be done. Like you didn't actually need to cut angles. And then like some of this like cutting and sawing was a little bit interesting, and I kept thinking that all of the members needed to touch, which in reality they didn't, so I spent like way too much time on that. But overall, I think it turned out pretty well. Also, another problem that we had was the gusset plates, where when we calculated the 15% of each member, we forgot that some of the plates will be touching two of like the 7.5 inch members. So it should have been like 30% of 7.5. So when we ordered the gusset plates, they were like really small. But so definitely in the future, maybe getting rid of those harsh angles, which was a little bit complicated in terms of like the creation, and then looking like deeper into what exactly we needed to be doing, and then maybe like asking the teacher specific questions that we might have had that we just didn't really originally do. Okay, so this is a picture of our truss when she was being loaded up and ready, and I'm gonna pass this off to Zane.
All right. So here's a picture of our full truss. As you can see, I have circled the failure point. You can kind of see that the um, lower member, member six, is falling out of joint E. Basically, our truss held up 283 foot-pounds until we had a glue shear failure point at joint E, where we predicted it might be at joint D, where the load was being applied. Um, Obviously, our prediction was not correct, and because our prediction was incorrect, it was incorrect. We had the right set of sections we chose. We chose to do when we were calculating, we knew it was going to be between joints D, E, and F. It just happened to choose, like when we did it, it happened to be joint D when we were solving. So I think we may have messed up one of the calculations for proving that joint D would have been um, the glue shear was greater in one of these other members versus E. So basically, that we knew which type of failure was going to be. I mean, it was, but other than that, we knew it was going to be a failure at joint E.
Mhm.
But yeah,
Another thing is that I had calculated the percent failure in terms of like shear stress, and I think just in general, and I think we calculated like our guesstimate was like 1,600 pounds or something. So I think our percent error was like 500%, which I think was a little like over the top. But I mean, I guess maybe we were just hoping that it would do really well. But I mean, also to back, we needed calculations to back our claim, so we couldn't just claim it was going to be like 300 pounds, even though we probably knew it wasn't going to make it that high. But I just wanted to add that in because it talked about percent failure. So basically, the
I
pictures that
didn't
we're
build this part of
showing
the
are like
presentation.
of the different sections. So this is, I believe it's Hamels, the 0101 honors. And then this is like highlighted the number of joints they had, which is our assumption that it was the same exact trust as we had had. And then it compares in terms of like their Pmax like total that they had gotten in terms of like the weight they got, and then like their height and width comparison compared to like what the stuff that we had occurred, and like trying to show the differences in terms of like the type of wood that they had used and like the height and width and like how it affected how much weight it was able to bear. And the same thing for like all some of the other sections as well, highlighted the same exact thing about like the changes in terms of like, oh, like if did their height increase and if their height did increase or decrease, like how much like P max were they actually doing and like able to hold. And then this is our grouping. And so all of us, I'm pretty sure with the seven joints are the same exact thing of they have like a similar width their height and like they're slowly increasing so you can see like a very large change exactly of like okay well their width is the same as ours but their height has changed so that means that like oh their Pmax is a little bit larger because of this specific thing mostly because that's the only thing that's specifically changing and I guess same exact thing like it's just a large comparison of the vast amounts of data that were taken over people doing specific things
Right.
yeah.
Right. So for trends, we found that overall people, like most groups, really overestimated the amount of weight that their truss could support. And as shown by our like 500+% error, it yeah, that's what happened with our group as well. And also glue shear and gusset plate failure was the most common failure method, but by far glue shear was like the most common. And the two truss teams that held the most load were the Magic School Truss and Terrapin Truss, and they were in different sections. Um, and the two that held the least were Toy Story and Trussell Sprout. Okay. And to compare our truss with the closest truss in another section, so Triceratops had like the same width, height, um, number of joints, and similar weight, but they ended up having a higher P max. But they did have the same failure mode as us. And based on our buckling calculations, we found that oak would have been a better choice for building the truss. And we also found that the taller the truss, the more weight it could hold, as shown by the truss teams that held the most weight.
Moving on to lessons learned. Um, During our trust building process, we, while it helped us learn a lot of lessons, the first and probably the most important one was that we should have started the math earlier because um, we kind of didn't start the math until the last minute or like a couple hours before the due date. And we were in a severe time crunch. And so we rushed a lot of calculations. And maybe that was why we also guessed the failure point wrong. But I could be mistaken because our calculations were also very extensive. Nevertheless, starting the math earlier would have definitely helped us a lot. Secondly, double checking to make sure we have the correct number of gusset plates was definitely an important thing that we didn't do. And once we realized it, it was too late. And so we had to go back to the wood shop and try and fix it. And thirdly, accounting for natural human errors. While calculating the failure points, we didn't really account for how our construction methods might have compromised the structure of the truss or like created points where failure could be more well, the truss could be more susceptible to failure. And so accounting for natural human errors was something we definitely skipped.
Yeah, just to add on to that, it was just more of like a focus on human errors is like obviously no one's going to build a next like we're not going to be able to use the same amount of glue and the same like using the same angle, making sure it's like perfect all the way across and we're covering the same area on each gusset plate. So it's kind of hard to calculate that it was going to be a perfect copy and paste all the way through because the CAD model is like a perfect representation in an ideal world in a vacuum where we do perfect. Whereas in like in person, obviously, as you can see in the picture, it's not like that doesn't travel super straight, and some of the gusset plates are a little larger, or they're shifted left or right, so they cover a little more on a different piece. So that really plays a big lesson, a big part of our like lesson learned that we kind of need to evaluate or factor some of that into our calculations as it would ultimately impact the overall load and whatnot of our truss.